We are now going to look at solving quadratic equations. Recall, for a quadratic in standard form, where y equals ax squared plus bx plus c, the zeros can be determined by letting y equal 0, rewriting the relation in factored form, and solving for x. So what we're doing is we're actually solving for the intersection of the line y equals 0 with the parabola, and that's where we find the two zeros. We did the same thing when we used symmetry. We let y equal c, the y-intercept, which helped us find the y-intercept and its matching point. In this section, we're going to look at solving for any value of y. So for example, if I let y equal 2, I'm going to try to find the corresponding x values. First, let's do a bit of review. Consider the quadratic relation y equals 2x squared minus 16x plus 24. What are the x-intercepts? So from the graph, we can see that we have the two x-intercepts at 2 and 0 and at 6 and 0. To solve for this algebraically, remember it's the same thing as finding the zeros, so we let y equal 0, and we get 0 equals 2x squared minus 16x plus 24. So remember, our first rule is to common factor first. So we end up with 2 times x squared minus 8x plus 12. Next, we want to factor the quadratic x squared minus 8x plus 12. So we need two numbers that add up to negative 8 and multiply to 12. Two numbers that work are negative 6 and negative 2. Since the a value is 1, we know that the magic numbers are part of our factors. So we have x minus 6, x minus 2. And finally, we solve for where each of the factors equals 0. So we have x minus 6 equals 0. So therefore, one of our x values is 6. And we have x minus 2 equals 0. So our other x value is 2. And again, those match the graphs where we had x equals 6 and x equals 2. So what about if we change the y value to negative 6 instead of 0? So here's negative 6, or y equals negative 6. And again, we see we have two x values, one at 2 and one at 5. So algebraically, we should end up with the x value of 2 and an x value of 5. So let's try this. So in this case, we're going to let y equals negative 6. So we get negative 6 equals 2x squared minus 16x plus 24. Same as when we use symmetry, we're going to rearrange so that one side equals 0. And the quickest way to do that is to remove the number from the left side. So we're going to add 6 to both sides. And we get 0 equals 2x squared minus 16x plus 30. Once we have 0 on one side, it's like we're solving for the zeros, so we're going to factor and solve. So first we common factor, and we get 2 times x squared minus 8x plus 15. So we need two numbers that add up to negative 8 and multiply to 15. Those two numbers are negative 3 and negative 5. So we get 0 equals 2. Remember, since the a value is 1, our magic numbers are part of our factors. So we get x minus 3 and x minus 5. Set each factor equal to 0. And then finally solve for x. So for the first x value we get 3, and for our second x value we get 5, which again matches our graph. X equals 3 is where y equals negative 6 hits the parabola first, and then x equals 5 is the second time the line y equals negative 6 hits the parabola. So let's change it for any scenario. It doesn't have to be just let y equal a number. As long as we have a quadratic on the left or right side or on both sides, we can solve using a similar method. So step 1 is always the same. Rearrange so that one side equals 0. So for this one, let's say I move the 4x squared to the left side, or minus 4x squared from both sides. I'm going to get negative 4x squared plus 18x minus 14 equals 0. And then the next step is also the same. We're going to factor and solve. So first rule is the common factor. So if I take out a negative 2, since my leading coefficient is negative, I get 2x squared minus 9x plus 7 equals 0. So I need two numbers that add to negative 9 and multiply to 14. So my magic numbers here are negative 7 and negative 2. So we get negative 2x squared minus 7x minus 2x plus 7 equals 0. So we split up that negative 9x. Next, we are going to factor by grouping. So if we take out a common factor of x, we get 2x minus 7, and leading coefficient is negative, so I'm going to take out a negative 1, and that leaves me with 2x minus 7. Notice these match up, and therefore we end up with negative 2, 2x minus 7, and x minus 1 equals 0. So continuing here, let's just rewrite it. This is negative 2, 2x minus 7, x minus 1 equals 0. We're going to solve for each bracket when it equals 0. So I get 2x minus 7 equals 0. So I get 2x minus 7 equals 0. Therefore 2x equals 7. And therefore x equals 7 over 2, or 3.5. And for the second bracket, I get x minus 1 equals 0. And therefore x equals 1. Now, my diagram up here is a bit different. It looks like a line and a parabola. If we go back to our equation, we have a line and we have a parabola. So what you've done, essentially, is you found the intersection of the line y equals 18x minus 14 with the parabola y equals 4x squared. You found the x values. So if you look at my graph, here is x equals 1, and here is x equals 3.5. So you just state the x values, but this would apply later on if you're trying to find the intersection between a line and a parabola. You would use the same method to find the x values, and then you can go back and find the y values. So let's try this again. This time we have two parabolas, as you can see in the picture, and as you can see with the equations, there are two parabolas there. The only difference between this question and the previous is that I need to expand. If we see brackets, make sure to remove them by expanding. On the left side, I have 2x squared plus 8x equals x squared plus x. Moving everything to one side, let's say we subtract x squared from both sides and subtract x. So I'm going to subtract an x squared, subtract an x. So what I do to one side, I must do to the other. I end up with x squared plus 7x's equals 0. Once I get to this stage where I have a 0 on one side, I'm going to factor. And of course the first rule is common factor. So I get x plus 7, and I don't need to go any further with the factoring. Last part is to solve for each of the factors. So I get x equals 0, and I get x plus 7 equals 0, which means that x has to equal -7. Looking at the graph, there's the point where the two parabolas meet at -7, and they also meet here at 0. Last example. A ball is thrown straight down from a 205.8 meter high cliff. So we have the y-intercept of 0 and 205.8. And a ball is thrown down from there and hits the ground. So our y-axis is h in meters, and our x-axis is time in seconds. Part A wants to know how long it takes to reach the bottom. Well, for part A, we are looking for this point, the 0. So we're going to let h equals 0, which gives us that 0 is equal to -4.9 t squared minus 4.9 t plus 205.8. So our first rule is the common factor first, and I would try out and see if all of these terms are divisible by 4.9. And you end up with t squared plus t minus 42. So this works out nicely. Next, we're going to factor this expression. So I need two numbers that add up to 1 and multiply to -42. Those two numbers are going to be 7 and -6. Since the a value is 1, we can use our shortcut, and we see that we end up with t plus 7 and t minus 6. Lastly, we can solve for the zeros, or the roots to this equation. So we get t plus 7 equals 0 and t minus 6 equals 0. The first time is at -7 seconds, and the second time is at 6 seconds. Hopefully you see that -7 seconds does not make sense for our diagram. We want the 0 in the positive x direction, so 6 seconds will be our answer. So therefore, the ball hits the ground at 6 seconds. All right, part B. Let's go back up and read it. How long does it take to reach a ledge that's 58.8 meters from the base of the cliff? So let's say there's a ledge sticking out here. It's 58.8 meters high. We want to know what this time would be. How long would it take to reach that point? So in this case, we're going to let the h equal, or the y, equal 58.8. So let h equal 58.8. So we get 58.8 equals -4.9 t squared minus 4.9 t plus 205.8. That gives us, if we rearrange, 0 equals -4.9 t squared minus 4.9 t, and 205.8 minus 58.8 equals 147. So now we need to solve this equation. So same steps as before. First, common factor. So take out the -4.9 in this example. That gives me t squared plus t and minus 30. So again, I need two numbers that add up to 1, but this time multiply to -30. So our magic numbers here are going to be 6 and -5. So our factored form for this expression is -4.9 t plus 6 t minus 5. And again, we see that our two roots are t equals -6 and t equals 5. We're not going to go back in time, so we're going to say that the ball reaches that ledge at 5 seconds. So therefore, to solve a quadratic equation for any y value, we sub in the y value, we move it to the other side, so therefore we have 0 on one side, and then we factor the expression and solve for x.